It's an afternoon talk, and everyone is getting slightly tired, and there was a lot of talking today. So yesterday night, I actually went early to my hotel room, and I started to look up like funny jokes so I can loosen up the atmosphere a bit. And it was actually complicated finding jokes that suit the topic, and also we Germans, we're not funny, so it's like there's almost impossible for me to do something that loosens up the whole thing a bit. But I try my best. So one of the first things I did was I was searching for SCADA jokes, and there's actually, you don't have to search for jokes, you just search for quotes about SCADA. And one of my favorite one is this one. So most public utilities rely on a highly customized SCADA system. No two are the same, so hacking them requires specific knowledge. It requires specific knowledge to hack a SCADA system, but to interfere with a SCADA system and interrupt it, it's basically, you don't even need to know the protocol, because all they know is the protocol, and if you speak something else, then they just go, oh, I don't know what to do, and stop working, and that's the worst case that can happen. Another quote from Bruce Schneier, the internet is still a dangerous place, but we don't foresee people or companies abandoning it. So that's from 2005. The economical and social reasons for using the internet are still far too compelling. So Felix has talked about Internet of Things, things being connected, telemetry, data flowing around back and forth, and this is basically what also happens in the industry. Like you see sensors, actors, things talking to each other. I mean, it makes sense. I mean, if the product tells the facility what to do, what it is, and what's the next step in the process, that's really compelling. That makes sense. That improves the system. It makes it more efficient. So let's talk about what I'm doing. And I create honeypots. I create honeypots since 5 years. And about 2 years ago, the Trend Micro published a report about setting up honeypots for ICS systems. And I thought, dang, I mean, we are the HoneyNet project. We should create those honeypots before the AV industry. So I came up and with a small honeypot that was able to speak Modbus. And I'm not an ICS person. I have no clue about the protocols until 2 years ago. But it took me half a day to create an ICS honeypot, because there's a Python module that knows Modbus, and I know how to set up TCP server, and bang, you have an ICS honeypot, you set it up, you wait for 2 days, and there's like weird stuff going on. Someone is talking PLC to my server. That's all I understood by that day. So I'm a German. I live in Norway. And actually, that's not a picture of me. If that were a picture of me, that would be a really sorry state for a German, because we try to convert to that state. Like, this is the optimum state. That's a beer belly. So if I were that person, and now I would look like this girlish figure, then something is really wrong. So that's not me, but still, it's very expensive here. So ICS security. What is ICS security? What is the biggest incident that can happen to an ICS facility? And it's basically something stops. That's the worst thing that can happen. It's not that something gets infected or that there's a virus on the system. That's not important. No one cares about this as long as the system runs. If the system gets interrupted, if something goes slow, if the telemetry is tainted, then it gets, like, people get aware and they try to fix it. So it's important to know this thinking. Like, it's not important if something is infected, it's important the system runs. So as I said, safety is important, reliability is important, and then comes security. And they're handling a lot of legacy devices, old embedded systems. So Felix said, a printer. Oh, something really important. If you don't understand what I'm saying, just replace ICS and SCADA and all those terms you don't understand with Internet of Things, because it's very similar. So it's a similar problem. The only difference is that the Internet of Things devices are usually like modern fridges, your car, but in ICS it's mostly old things that have more difficulties to be changed and updated. So in ICS security, it's old devices. Some of them don't even have a security certificate. They have a safety and reliability certificate. they run. The vendor says this system will always run, but the vendor never says this system is always secure. And if it's not secure, then we patch it. They don't say this because patching it is complicated. And it requires a lot of testing, and you have to recertify something if you patch it. So instead of protecting the infrastructure, they protect the data that's flowing, because that's important. There's no interruption should happen to the data. Everything should go really fast, really reliable, no interruption, no loss of data. So as I said before, it's not the security that's guaranteed, it's the robustness of the system. And only robust for the specific use case for that PLC. No one expects something to talk in HTTP to a Modbus PLC. If that happens, then there's they cannot predict what happens to the system if it stops working or if it continues running. It's guaranteed for this specific use case for reliability and for continuous running. And the problem behind this whole system is that people don't like to change. I mean, we all know this. Moving around is really painful. Patching is painful because you have to sometimes shut down your Windows PC, reboot, and it tells you again to shut down and reboot. So that's really we don't like this. We want things to run and work and not being interrupted. And also security is still a cost factor. It shouldn't. And especially in ICS, security is a big cost factor. Reliability is not a cost factor, but security is. And that's something that also has to change. And finally, the vulnerability lifecycle. If you see a report about a SCADA ICS incident, this report, the event is usually over a year old, because they have to patch all the systems. It takes forever. So, short introduction to ICS security, and now talking about the honeypot I developed, which is called Honeypot. So there wasn't a lot of introduction about honeypots. It's actually interesting because I was expecting someone to introduce honeypots before I start talking about Honeypot. But basically, a honeypot is a system that gets put out there, and you wait for people to connect to it and do stuff with it. So Lance had sort of an introduction that was very high level. So when you talk about security risk, then this is basically a function of likelihood of a successful attack and also the consequence of that attack. So if you set up a honeypot, then you want to have a high security risk because you want to see stuff happening on your honeypot. So that means you put it on a public IP address, you maybe promote it, you can post your IP addresses to a forum, you can tell Google about your honeypot. So likelihood of successful attack, that's something we want to increase if you want to see people using our honeypot and interacting with the honeypot. Likelihood of successful attack is, again, a function that can be roughly put together as the threat. So how many people are actually trying to attack a PLC system or ICS system? Then the vulnerabilities that are present. So if there's only one vulnerability, it's very unlikely that you have this vulnerability. But if there's a lot of vulnerabilities, then it's likelier that you have this vulnerability, and so that increases the likelihood of a successful attack. And finally, target attractiveness. This is something very, very important for a honeypot, especially in the ICS. When it comes to ICS, because in ICS, most of the attacks are, at least what I can tell from my data analysis, is that most of the attacks are still kind of targeted. That has also to do with the first quote I showed, that the ICS infrastructures are kind of custom, so you have to figure out what kind of layers there are until you reach sort of your target. So most of the attacks are still kind of targeted, or at least select their targets very carefully. So the target attractiveness is something you have to work on, you have to improve, and that's something also I want to talk about right now. So this is another quote. Thus, the expert in battle moves the enemy and is not moved by him. And this is basically what deception is, right? We don't want to react on the attacker. We want to make the attacker do something what we tell him to do. So that's basically a honeypot. We let someone in our system, and then we say, okay, here's the system, and If you ask me, then I will give you more IP addresses so I can direct your path in my system. I can direct your lateral movement. I can control what you are seeing. And I can control your decision making. If I show you a web interface, I can be almost guaranteed that he's going to try like the basic cross-site scripting SQL injections. If I give you a document, I'm almost certain that he will open a document and see, hey, is there something interesting in this document that I can sell or use to further transfer in the environment. So I want to control the system, and I want to control the person using my system. This is an example of how not to deploy a honeypot. If you haven't seen this before, this is Shodan. This is basically a search engine for industrial things that are connected. And Conpot, or the honeypot, has a default configuration which you should always change because it's an easy searchable fingerprint. And this is actually a Conpot that was deployed by a company in a company's IP range that ends, which names end with corporation, so you can figure the rest, I guess. It's a big company in the US. So where do you deploy an ICS honeypot? And basically, you can deploy it everywhere. Yesterday, someone mentioned to me that it doesn't make sense to deploy an ICS honeypot at your home, in your home system. But actually, it's not true. At least if you're in Norway and you open your, like in the entrance, there's like a small cabin, and if you open it, there's an electric meter. And in Norway, we always like read the meter and send it into the power company. And that gives us the control, and we can see what's happening. And we had Kamstrup support in our honeypot, and Kamstrup is a vendor for smart meters. And there was a colleague of me implemented a protocol, and I thought it's really interesting. And he said, yeah, they're using Kamstrup in Denmark, and I never really thought about it. And then one day I opened the cabin and like typed in the meter reading, and I said like, oh, this is a Kamstrup. So there's a Kamstrup meter running in my cabin, and if you remove the ceiling and open the meter, you can plug in an Ethernet cable, you can reset the reader, you can start it, reboot it, configure it basically. And that's really interesting, and a lot of people, they don't think about this kind of stuff that runs in their home and that has vulnerabilities. So setting up a honeypot can be quite interesting, even at home. You can set it up in your company as a decoy, so you see someone interacting with the honeypot before it hits your real infrastructure. And you can do global deployments as we do it. And I actually want to go into more detail about the global deployments, and there's actually two methods. One we call the thick deployments and thin deployments. Thick deployments is basically you set up a complete honeypot with all the protocols, maybe some hardware, but it means you have to, like, it's a lot of interaction. You have to set it up manually, you have to configure it, you have to change configuration, you have to maybe ship hardware. You are able to combine our virtualized emulated honeypot with real hardware to make it more interactive and more interesting. But this also gives away control over the system itself. And on the opposite side, we have thin deployments. And thin deployments is basically, we have one central server that runs all the things, the Conpot, and you can have different ones, different instances, but it's locally on your system. You have control, and if you want to change something, it's just, it's nearby. It's not in the cloud. And what you put out there is basically a traffic reflector. So it's an endpoint that looks like it's running something, and if traffic comes in, it reflects the traffic down to our central control system, our emulated factory, and then the response from the factory goes back up through the traffic reflector to the attacker. That means all we have to deploy globally, like in different data centers, is a really thin layer that basically forwards traffic and sends it back. And one of the problems you always have is how to hide the fact that we are honeypot. And there's some easy things you can do to detect in honeypot. What's the IP range the honeypot is deployed in? I mean, who expects a PLC running in the AWS, the Amazon hosting IP range? And I see a lot of those honeypots running there, and I think like, come on, put in a little bit more effort. Then you have the IP address. And even maybe it's deployed somewhere that looks okay-ish and fine, and then you do an nmap-o, so you see the operating system Nmap is basically a scanning tool that fetches a couple of indicators about the system, and then depending on a couple of fingerprints, it decides what kind of operating system is running. And actually, I have one of those fingerprints, and it looks completely like Chinese, but it's basically a couple of criteria, and if a lot of them are matching, then it gives you with a certain reliability that this operating system is running on this IP address. And so in this case, this is a fingerprint for a Symmetric 300 PLC. It's very common deployed PLC hardware. And what we did to sort of hide the fact that our honeypots are running on Windows servers, running on Linux machines, is that we reversed the whole process. So instead of replying with the regular TCP shapes from the Linux machine, we took the response from our honeypot and sort of repackaged it. So we took the package itself, stripped away all the headers and lengths and whatnot, everything that sort of defines the fingerprint of Nmap, and we repacked it based on the fingerprint. So what you get is, you give our library a fingerprint, and it reworks all the packages according to that fingerprint. So if you see a report on Shodan saying, we found 500 iPhones being connected via Ethernet to some IP address, then it's probably us messing around with them by deploying our OS obfuscation technology and pretending to be iPhones or pretending to be iPads or whatever device there is a fingerprint for, we can emulate it. And so that means if you have a smart fridge and you know the fingerprint, the Nmap fingerprint of that smart fridge, we can use our OS obfuscation to turn our honeypot into a smart fridge. And it's actually 2 lines of Python. Easy. That's a low-hanging fruit to hide the sort of identity of your honeypot. Every time I give a talk about Compot, people ask me, hey, so you have this honeypot deployed, and what kind of data do you see? And I'm not really a data analyst and scientist, and I see the data coming in, and I came up with a small script that gives me really raw, high-level numbers. And as a disclaimer, those numbers are not sort of cleaned or whatever. So what you see is a really raw numbers, and I'm not going to put any weight on it because they could mean anything. But I just want to give you some numbers that gives you sort of an understanding, maybe a hint what it means to run an ICS honeypot. So what you see up here is the countries that have connected to my honeypot and used a protocol that's an ICS protocol. That means they understood what kind of system is running on that machine, and they understood what kind of language they have to speak with the machine in order for the machine to respond with the information they were looking for. So in the top row you see, I hopefully didn't mess it up, but that's mostly European countries. So you see Switzerland, Germany, Denmark, Netherlands. In the lower row you see Russia, US, China, and Israel. And those are actually the most common people that show up. This is really bad attribution. Those are the IP addresses that reached my honeypot. But you see it's a reasonable distribution of IP addresses. Then I have some information about the protocols that were sort of spoken between the person creating the event and my honeypot. And it's mainly Modbus and S7com. Modbus is a really old protocol, and lots of devices are still speaking it, which are out there. And as you can see from the commands, and I think everyone can understand what it means, they're basically reading information about the device, about the slaves that are running. In here they have diagnostics, so this gives you some information about if the system is running, what kind of hardware is running, and then setup communication. This is actually something really interesting that tells me they're trying to do something, but they cannot really go further because we are probably not supporting it properly. And S7com is a protocol developed by Siemens. It's proprietary protocol, so we had to reverse engineer the protocol to sort of provide some kind of interaction. So my time is almost up, but I'm almost at the end of my presentation. So the event count is actually very low. This is for 1 month of running the Honeypot. But it's something you have to expect. It's not an HTTP server where you have, like in a minute, you see thousands of requests coming in, people crawling and whatnot. And the Honeypot also runs on web interface, and there's like thousands of events every day. But this is something everyone sees in his web server logs. Okay, so the Conpot itself, the Honeypot, is something that allows you to create a PLC system. It's not an out-of-the-box power plant, but it allows you to create a complex system. So I recently talked to someone who created a train control system using Conpot, using some real hardware. They actually had a model train going round, and if someone interfered with the system, the train actually could derail. And they see people derailing a train. And they had actually also a web interface where you can see the surveillance cams. So you can see people getting out and into the train, and someone actually made the train to derail. So if they understood what they were doing, they were taking the risk of injuring someone. But I mean, it could be some random TCP package that made the PLC go foobar and derail the train, because they don't expect someone to do something weird to them. Okay, that's the end of my presentation. And I want to repeat what Lance said. We don't need money from you guys, but we need appreciation. And appreciation for me means send me beer. You can also visit me in Norway, so you don't have to send the beer, so just bring it from duty free. Okay, thank you very much.